polynomial will be if it is Maclaurin series is used, it's the name itself suggests that it is series. It will become finite if your function is a finite polynomial, correct? And it will become otherwise infinite. We saw now sine x. What is the expansion of sine x? X minus x cubed by 3 factorial plus x raised to 5 by 5 factorial dot dot dot. What does that dot 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 mean? It is an infinite series, correct?
Yes, ma'am.
Yeah,
Yes,
and when
ma'am.
it, yeah, and when it is a function of the type f of x is equal to 3x cubed plus 2x square, and if it is asked expand it in powers of x minus 2, then it has finite term because a function only is a finite polynomial. So it cannot become an infinite series. So basically it depends on the function, but we can write it as an infinite series with the coefficient as 0, 0, 0, 0. 0 into x raised to 4, x raised to 5. If it is a function of degree 3, it will stop at the third derivative, x cube. Then further terms are 0 because the derivative of constant is 0. However, it can become an infinite series if I write down the coefficients as 0. So Maclaurin series is nothing but what is the definition? F of x is equal to f of 0 plus x f dash of 0 plus x square by 2 factorial f double dash of 0 and so on. So what is happening over there? We want f of 0, we want f dash of 0, f double dash of 0. So the function should be differentiable. Are you getting it? Maclaurin series
Yes,
or
ma'am.
Taylor series can be written if we can differentiate the function. So if suppose the function is not differentiable, then can we write it as an infinite series? Then comes into picture Fourier series. Fourier series can be written even if the function is discontinuous. But the discontinuity should be finite. It should not become infinite at that point. Wherever there is discontinuity, the function should not become infinite. Okay, for example, 1 by x. This function, if you want to write down in the Fourier series expansion, and x is involved in the interval where it is defined, then it cannot be defined because 1 upon 0 is infinity. So we cannot, we are having the discontinuate 0 and it is becoming infinity. So for that, we cannot write down the Fourier series. Fourier series can be written for a finite function, means the value of the function should be finite. It should be integrable because Fourier series expansion will be written with the help of integrations. Then it should be periodic function because we are writing f of x in terms of sine and cos, so it is a periodic function. Then it should have, if it has discontinuity, those should be finite. If it has maxima minima, those also should be finite. These are the Dirichlet's condition. For this condition only, we can write down Fourier series. But what is the plus point of Fourier series? As in case of Maclaurins and Taylors, which could be written only for a continuous and differentiable function, even if the function is discontinuous with finite discontinuity or not differentiable with finite differentiability, that is point where there is differentiability is not there, that finite point is there, then only we can write down the Fourier series expansion. Is it okay? Is this clear? What is the difference between Fourier series and Taylor series or Maclaurin series?
Yes, sir.
Yes.
Okay, there we could write it for the function when it is continuous. Here we can write it even if the function is discontinuous. So this will be useful for periodic functions as well as discontinuous functions with finite discontinuity. Even if it has maxima minima, it should have finite maxima minima. Okay, so let us first write down the basic definitions which we require. The first definition which we require in case of writing a Fourier series is periodic function. Periodic function. So do you know any periodic function? Have you come across any periodic function till now?
Sine x.
Yes, sine x and cos x, these are periodic functions. And that's why basically when it started, Fourier series was written, it was written in terms of trigonometric terms only, sine and cos. We will see the definition, you will come to know. So now let us actually write down what is the definition of Fourier series. So, what is the definition of periodic function? F of x, a function f of x is said to be periodic function with period t, which is a positive number, if f of x plus t is equal to f of x for all x. Do you understand the meaning of this definition? F of x plus t is equal to f of x means it repeats itself after the time t, after the period t. Is that state definition clear to everyone? F of x plus t is f of x means it will repeat itself after the period t. For example, I'll give you an example. For example, sine of x plus 2 pi. We'll make use of the formula sine a plus b. So with the help of that, what is this formula? This is sine x into cos of 2 pi plus cos x into sine of 2 pi. Correct? But what is cos of 2 pi? It is 1. And what is sine of 2 pi? It is 0. Therefore, what's your answer? Sine x. So, sine is repeating itself after 2 pi. So, what's the period of sine? Period of sine is 2 pi. Is this clear? Everyone?
Yes, ma'am.
Sine, yeah. So,
Yes.
sine is said to be periodic function of period 2 pi. Is this everyone is clear then? Please tell me what is the period of cos x? What is the
2 pi.
correct? Cos x is also of same period because cos of a plus b. What's the formula of cos a plus b? Correct, everyone. Yeah. Umesh, it is right. So what is cos of x
Cos A,
plus?
cos B, minus sin
Yes, cos a cos b minus sin a
sin A, sin
sin b. But again, sin of 2 pi is 0, cos of 2 pi is 1. So your answer is cos x. Therefore, cos is also periodic function of period 2 pi. Is this clear? What about tan x?
Pi.
Yes. Period of tan is pi. Because what is the formula of tan a plus b? Tan a plus tan b divided by 1 minus tan a
tan A, tan
tan b. But tan pi is 0 and therefore this is tan x. And which is true for all x. Hence, tan is periodic function of period pi. Clear, everyone?
Yes, ma'am.
Okay.
Yes,
please,
yes,
so please write down now the definition. A function f of x is said to be periodic. I have written everything on the board. A function f of x is said to be periodic with period t, which is a positive number, if f of x plus t is equal to f of x for all x. If f of x plus t is equal to f of x for all x. For example, sin x, cos x are periodic function with period 2 pi, are periodic functions with period 2 pi. Tan x is periodic function with period pi. Tan x is periodic function with period pi. Okay. Fine. So this is about the period. Now let us talk something about fundamental period and the general periods. So suppose if 2 pi is the period, what can you say about 4 pi, 6 pi and so on for sin x? Are these also the periods of sin x? Is sin x plus 4 pi equal to sin x? Is sin of x plus 4 pi, is it sin x?
Yes, ma'am.
Okay?
Yes, ma'am.
Everyone? Because what will be the formula? Cos of 4 pi, sin of 4 pi, which is 0, no? Sin of 4 pi is 0, cos of 4 pi is 1. So every time when you are writing multiples of 2 pi, those are also the period of the function. Are you getting it?
Yes, ma'am.
So the note is if t is the period of f of x, then 2t, 3t, 4t, and t for n positive integer is also the period of function f of x. Is this okay? Please write down this note that if t is the period of f of x, then 2t, 3t, 4t, n is not 0 obviously. For n not 0 and positive integer, it is also the period. समझ में आया? multiples of that t are also the periods. Now, but there is something special about that t, na? So that is the minimum. The smallest among all such periods is called as the fundamental period of the function f of x. So you write down after this. This is note 1 which we have written. If t is the period, then 2t, 3t, 4t, dot 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 nt. These are all the periods of the function n not 0 and positive integer. However, you can write down note 2. The smallest among all the periods of f of x, the smallest among all the periods of f of x is said to be fundamental period of f of x is said to be fundamental period of f of x. Okay?
Ma'am, please repeat that smallest among.
The smallest among all the periods of f of x, the smallest among all the periods of f of x is called the fundamental period of f of x. Is called the fundamental period of f of x. Example, sin x has 2 pi, 4 pi, 6 pi, dot 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 as periods of x, sin x, as periods of sin x, but 2 pi is the fundamental period of sin x. 2 pi is the fundamental period of sin x. Clear?
Yes, ma'am.
Yes, ma'am.
Okay, thanks. So then there is one more important note, because these are the things which will be asked in your MCQ. So I'm doing it. You just think about it and try to tell me. If t is the fundamental period of f of x, this is very interesting. If t is the fundamental period of f of x, what can you say about the period of f of ax? What will be the answer? What will be the period of f of x? Just try for sin x only. Sin x is 2 pi. Then what will be sin 2x? Ax means what? A is a non-zero number. So if it is multiple of, if it is 2, 3,
T by
4,
A.
very good. Everybody, are you getting it? Yes, it is t by a, not multiplied by. कैसे देखो? Okay, so it is t upon a. Now listen carefully, okay? Sin x, I draw the curve. 0 up till 2 pi. What is sine of? I'll write this as pi by 2, this is pi, this is 3 pi by 2 and 2 pi. Correct? Please listen carefully, okay? So what is the curve of sin x? Sin 0 is 0, sin pi by 2 is 1, sin pi is 0, sin 3 pi by 2 is minus 1 and sin 2 pi is again 0. So I will draw it smoothly and your curve will be like this. Okay? Is this correct? Sine wave?
Yes, ma'am.
Everyone?
Yes, ma'am.
Now you try to draw the curve for sin 2x. Between the same one, huh? This is 0, this is pi by 2, and I write here pi by 2, then pi by 4, then 5, and then I write here 2 pi. In between there are many terms also, 3 pi by 2, this is 5 pi by 4, 7 pi by 4 and so on. Yeah, now tell me, length is same, 0 to 2 pi. Can you see this? 0 to 2 pi. Here also it was 0 to 2 pi. What is the curve you are now telling? When x is 0, sine of 2, 0 is 0. When x is pi by 2, what is sine 2 pi by 2?
Sine pi.
Sine pi. And what is sine pi?
0.
0.
Very good. So you will be here. What about x is equal to pi by
1. It will be
Sine 2
Yeah,
pi
1.
by 2. So it is sine pi 2 pi by 4. So it is sine pi by 2. So it is 1. Okay? Clear? So it will be like this. And then it will be like this. समझ में आ रहा है क्या?
Yes, ma'am.
yes,
Yes,
ma'am.
ma'am.
Again, it will be like this. And it will go like this. So here there was only one cycle. So the period was 2 pi. Is that clear?
Yes, ma'am.
Yes, ma'am.
And then this was not repeated, it was totally different. इसके बाद वो repeat हो रहा है. So what's the period? One cycle it is. So 2 pi period. What about sine 2x? 0 to 2 pi में कितने cycles आ रहे हैं? This is one cycle and this is second cycle. So there are two cycles ना? मतलब repetition
Yes,
कहाँ
ma'am.
से? Actually repeat कब तक हो रहा है? 0 to pi तक ही वो fixed है. Same repeat हो रहा है 0 to 2 pi. तो period क्या हो गया आपका? 2 pi upon 2. What is the formula for period? The total length that is there divided by your number of cycles, or you can say wherever there is no repetition. यहाँ से 0 से pi तक जो कर्व आ रहा है वही pi से 2 pi तक आ रहा है. So what is your period? 2 pi by 2, which was the period for sin x divided by 2. So t by a. Is this clear?
Yes, ma'am.
Yes, yes.
सबको समझ में आया?
Yes, ma'am. Yes, yes.
Very good, very good. So if I have sin 3x, so what will be your period for this? 2 pi by 3. 2 pi is the period of sin
Yeah,
x
ma'am.
divided by 3. So you will get 3 cycles, and that's why you are getting the period has to be 2 pi by 3. Okay, everyone?
Yes, ma'am.
Yes, ma'am.
Very good. So you write down this note because this is very important for from MCQ point of view. If t is the fundamental period of f of x, if t is the fundamental period of f of x, if t is the fundamental period of f of x, then t by a, then t by a is the fundamental period of f of ax, a non-zero. Then t by a is the fundamental period of f of ax, where a is non-zero. So tell me what is the fundamental period of tan of 3x?
Pi by 3.
Pi by 3.
Yes, tan x का period है pi, and therefore tan of 3x का period होगा pi by 3. Is it okay? Because a is equal to 3. Clear to everyone?
Yes, ma'am.
Yes,
Yes.
ma'am.
Okay, so that is about the fundamental period of function and f of ax. If t is the period of f of x, if t is the period of f of x, then t by a is the period of f of a by x. If t is the period of f of x, I'm repeating for you. T is the period of f of x, then t by a is the period of f of ax. Okay? Clear?
Ma'am,
Yes,
Yes,
Parth?
yes.
if f of x by 3 was there, then
Huh?
time period will become 8 into t, no?
Correct, correct. Because a is 1 by 3, na?
Okay, ma'am.
A will become 1 by 3, so it will be divided by 1 by 3, so it will go on top. Correct. So if it is tan of pi by x by 3, then a is 1 by 3, so you have to divide by 1 by 3, so it will become 3 pi. Okay, because your cycle will get extended. यहाँ पे वो shrink हो रही है, वहाँ पे वो extend हो रही है.
Okay, ma'am.
Okay, so that is clear to everyone. What is the meaning of periodic function? It should repeat itself, and the period will be given to you in the questions. If t is the period, t by a will be the period of f of ax, and so on. Now let's go to the next definition, which is also required in case of Fourier series, that is even odd function. Should I rub this?
Yes.
So, what is the meaning of even function and what is the meaning of odd function? That we will see now. Okay. So, if your function f of x, we want to talk about whether f of x is even or odd. How do we do it? Even or odd के लिए symmetry देखते हैं. We try to see the symmetry about origin. We try to see symmetry about origin. So, in this on this side, what is x? X is positive. Correct? On this side, x is negative. Yes or no?
Yes.
So if I'm saying that if I'm saying that this curve is even, then I'm talking about the symmetry about y-axis. What we are going to do? If f of minus x becomes f of x, if f of minus x is equal to f of x for all x, then I say that f is even function. Is it okay? For example, if your f of x is x square, if your function f of x is x square, what will be f of minus x?
X square.
Yeah, it is minus x the whole square, ना? लेकिन minus x का whole square क्या होगा? Plus x square होगा, which is f of x. So who is even? F of x is equal to x square is a even function. Clear?
Yes, ma'am.
Okay, fine. So for example, here x square. How do you plot it? Y is equal to x square. This is your curve. When x is positive, x square will be here. X is equal to 0, it is 0. It's a parabola, na? So this is a even function. Is it okay?
Yes.
Everyone, समझते हैं ना? Graphically then नहीं समझ तरी algebraically are you getting? F of minus x is equal to f of x. F is said to be even if this condition is satisfied. For all x, even if I put x negative, I should get the same answer as x positive. So that type of function is called as an even function. Can you give me some other example, trigonometric example?
Cos x.
Cos x.
Absolutely right.
Okay.
Correct. So if f of x is cos x, then f of minus x is cos of minus x. But what is cos of minus x? It is cos x. Cos of minus x is cos x, and therefore you have that cos is even function. What about odd function? Now this was the definition of even function. What is the definition of
F
odd
of
function? Very good. If f of minus x is equal to minus f of x for all x, then I say that the function is odd. Then I say the function is odd. So what is example in algebraic equation? F of x is equal to x या फिर x cube. X cube. So what will be f of minus x? It will be minus x, which is minus of f of x. Correct? समझ में आया ये? F of x is x. So what will be f of minus x? X की जगह पे minus x put करना है. So that is nothing but minus of x, which is minus of f of x. Clear?
Yes.
Yes, ma'am.
Okay. Similarly, f of minus x cube will be minus x cube, which is minus. अगर आपका function f of x है, so minus f of x. So this is also odd. This is also odd. Trigonometric function.
Sine.
Sine.
Sine x, very good. So sine x is an odd function because f of minus x is sine of minus x, which is minus sine x. So these are your odd functions and even functions. Clear, everyone? So please write down these definitions. Write down this definition quickly. A function f of x is said to be odd. A function f of x is said to be odd if f of minus x is equal to minus f of x, f of minus x is equal to minus f of x for all x, and
Ma'am, f of x, what
is
you
equal
said
to
there?
f of minus, a function f of x is said to be odd. A function
Okay.
f of x is said to be odd. I've written this on the board. If f of minus x is equal to minus f of x. If f of minus x is equal to minus f of x for all x, then f is said to be odd. For example, x cube, these are odd functions because minus x raised to odd power is negative, and that gives you the sign of f of minus x to be minus f of x. X की जगह पे when I replace minus x, I get here f of minus x is minus x, which is minus of f of x, and therefore the function x is odd. Similarly, x cube, minus x cube is negative. Okay. I've written here like this, but actually it is f of minus x will be minus x cube, which is minus of f of x, and therefore it is odd. Similarly, sine function. If f of x is sine x, f of minus x will be sine of minus x, which is minus sine of x, and therefore your function is odd again. These are the examples. Next definition is even function. Write down. If f of minus x is equal to f of x for all x, negative, positive. If f of minus x is equal to f of x for all x, then f is a even function. F is a even function. For example, x square, cos x, and so on. X square, cos x, and so on. Is this clear to everyone?
Yes.
Yes.
Okay, very good. Yeah, very good. Now you tell me, what will be product of even function into even function? Take some examples and try to find out. There are conditions which are not. Suppose f of x is even and g of x also is even. Then what can you say about product of f of x into g of x? Take some examples and try to convince yourself. Give me two examples of even function.
Even.
Give me example of even function. Yeah. Easy examples. X square and
Cos x. X raised to 4.
okay. Easiest one is x raised to 4, but this also we'll see, right? So what is the expansion of cos x? You know, right? It is 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial and so on. So when you multiply this x square inside, all of them will be even powers only.
Yes, ma'am.
So your function is even. So your function is even because when you put x is equal to minus x, हर जगह पे even powers है, तो even power negative number raised to even power will be positive only. So it will remain same, and you get f of x, which is very easy to understand from f1x into g1x. If suppose the question is x raised to 2 into x raised to 4, so total answer is x raised to 6, which is even. Why? Because when I replace f1 of minus x into g1 of minus x, it will be minus x the whole square minus x raised to 4, which is x raised to 6 again, which is plus f1 of x into g1 of x. This is by definition. But clearly you can see if the power of x is even, it is an even function. Yes or no?
Yes, ma'am.
Everyone else also? Om? Everyone?
Yes, yes.
Yes, ma'am.
Yes, yes.
Yes, ma'am.
Okay. So the product of even function is even. So first note is, write down the first one. Product of two even functions is even. This is going to help you to identify the integrations. Okay, that's what I'm writing. Note 1. Product of two even function is even. Yes. Note 2. What can you say about if f of x is even and g of x is odd? Example, f of x say is x square and g of x is say x. This is even, this is odd. So what's the product? Is this clear? So it is x cubed. Therefore it is odd. And this will be true for others also. If it is sine x, it will have odd powers. So powers of odd number plus 2. So it will become odd only. No? Are you getting it? Everyone samajhte ka?
Yes, ma'am.
Yes,
X square, yeah. So you make the second note. Product of even and odd function is odd. Product of even and odd function is odd. Tell me, do we have to write the case of odd into even?
Same only, ma'am.
Same it is. कुछ लिखने की जरूरत नहीं. पहले ये मल्टीप्लाई करो या ये मल्टीप्लाई करो. It is one and the same thing, ना? So that case we don't have to take. समझते का? F of x odd असेल and g of x even असेल. Then also I get the same type of answer. So the case of odd into even is same as even into odd. It is odd only.
But order it will be different.
Yes, but what about product of odd into odd? Suppose f of x is odd and g of x is also odd. Then what about the product? F of x into g of x. Say it is x into x cube. So what's your answer?
Even.
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 X4.
Even. Is this okay? So you have to write down the next note. Product of two odd functions is even. Product of two odd functions is even. Product of two odd functions is even. Note 3. Product of two odd functions is even. Is this okay? Clear? Everyone?
Yes, ma'am.
Yes, ma'am. Yes.
Let me ask you about one question. Mod x, is it even or odd function? What is mod x? Is it even?
Even.
Very good, very good. Because f of minus x is mod of minus x. But what is mod of minus x? It is plus x only. Is it okay?
Yes. Yes,
So
ma'am.
answer is
Yes,
even
ma'am.
function. Mod of minus 1 is 1. Mod of negative numbers is positive only. Clear, everyone? So mod x is even
Yes.
function. X square is even function. Cos x is even function. X is odd function. X cube is odd function. Sin x is odd function. Tan x is odd function. Okay? So if this is clear, periodic functions and even odd functions. Now let's go to the basic definition of Fourier series expansion. So let me write down the definition. Okay. A function f of x, please write down along with me and then we will see how to understand it. First you write down. A function f of x, periodic, a function f of x, periodic in the interval c less equal x less equal c plus 2l, periodic in the interval c less equal x less equal to l with period 2l satisfying Dirichlet's condition has Fourier series expansion as f of x is equal to a naught by 2, f of x is equal to a naught by 2 plus summation n from 1 to infinity an cos of n pi x by l plus bn sine of n pi x by l. If f of x is a periodic function in the interval c less equal x less equal c plus 2 pi with period 2l satisfying Dirichlet's condition is given by f of x is equal to a naught by 2 plus summation n from 1 to infinity an cos of n pi x by l plus bn sine of n pi x by l where a naught is equal to 1 by l integration c to c plus 2l f of x dx, where a naught is equal to 1 by l c to c plus 2l f of x dx. an is equal to 1 by L integration C to C plus 2L f of x into cos of n pi x by L dx. So please see in the definition we have integration. Okay, so we'll have to do this integration and Bn is equal to, can anybody tell what will be the formula for Bn if you could relate f of x and what I am writing for the formulas of a naught an? Can anybody think what will be the formula for Bn?
Ma'am, in place of cos, there will be sine.
Absolutely right. So 1 by L C to C plus 2L f of x into sine of n pi x by L. This was the definition given by Fourier for the expansion of f of x in terms of sine and cos. F of x was periodic function. So what are the most periodic functions known to you? Sine and cos. So depending on the period, here the period is 2L, okay, and that's why this which is there now, this angle is in the form n pi x by L. N pi x by L. So how you get this formulas of integration, that I'll tell you in the tutorial class, because the derivation part is not there for you all, but you should know, that's why I'll do it in the tutorial class. But right now, how to use this, what is the meaning of Fourier series and how to use this, those examples we will try to solve first. Okay, so I'll repeat once again. If your function is periodic, that means it is repeating itself in 2n period and satisfying Dirichlet's condition. I'll tell you what are Dirichlet's condition. Then the function has Fourier series expansion being periodic. It will be written as a summation of cos and sine, which are periodic functions. Is this part clear? Why f of x is written in terms of sine and cos? The most general periodic functions that you know are cos and sine, and that's why to fit into the periodicity, we have tried, Fourier tried to write it in expansion of this form, and it worked. Is this okay?
Yes, ma'am.
Yes.
Yeah. So now, yes, very good. And where I am writing, how I am finding a naught, an, bn, that comes from here. This definition was given, and then what will be the values of a naught, an? Those were found, and we will see that how actually the formulas came out to be this. For that, you should know the integration formulas. Integration formulas of cos into cos, integration formula for cos into sine, sine into sine, when they are zero, when they are non-zero. That will help you to give this formulas. Okay, so that I'll explain you in the tutorial class how we get this integration formulas. But what we have to do now, you will be given a general function f of x, which will be either continuous or discontinuous, or it will have finite discontinuity. Then we will be able to write this the Fourier series expansion with period of that function to be 2L. How I get that 2L? Your question will be given as f of x is periodic function between 0 to 2 pi. Then what will be, how will you find 2L? How will you find the value of 2L? Suppose f of x is equal to x is your function defined in 0 less equal x less equal 2 pi. F of x is equal to x in 0 less equal x less equal 2 pi. Tell me, how will you find L? How will you find L?
2 pi by 2.
Yes, just see here. C to C plus 2L. Na? So how did I get to L? Upper limit minus lower limit. Everyone please listen carefully. This is the part which is very important to find L. They will sometimes give in the question also, but still, if it is not given, either you divide the total period by 2, or, because I want it here, na? When I want to find A0, A and B, I want to find what is L. So how you are going to do that? Upper limit minus lower limit will be 2L divided by 2 is your L. Is that clear?
Yeah, ma'am.
Everyone?
Yes, ma'am.
Okay. So we'll see the examples later on. First to write down this definition. Then we will see all possible definitions itself. If suppose your interval is between 0 to 2 pi. If suppose your interval between minus L to L. Then what are the formulas and how do we get it? So first to write down this. Please write it. I'll give you the Dirichlet conditions also. First to write down this. F of x is a periodic function in the interval c to c plus 2l with period 2l, satisfying Dirichlet's condition. Satisfying Dirichlet's condition. Then it has Fourier series expansion given by this. Now, how will you also remember the formulas? See, a naught is alone. It is present alone. So you just integrate f of x from c to c plus 2l. 1 by l will come. because of that integration only. So a naught is associated with f of x. Just integration of f of x 1 by n. An is the coefficient of cos. So formula for an will be 1 by l f of x into cos. Okay, and Bn is associated with sine, so formula for Bn will be 1 by l integration of f of x into sine. That's the way you should be able to write down the formula. Is it okay? How to set
Yes,
the mind
ma'am.
map? How to set the mind map? Since Bn is the coefficient of sine, integration of Bn will have f of x into sine. Since An is the coefficient of cos, integration of An will have f of x into cos. Since a0 is the coefficient of cos 0, but what is cos 0? 1. Therefore, f of x into cos 0, that is only f of x. So, a naught integration will have only f of x. Clear? This way you can remember the formula also.
Yes, ma'am.
Yes.
Yes, sir.
Okay, fine. What is Dirichlet's condition, and then we'll write down the different definitions of Fourier series. Okay, fine. So take down. Dirichlet's conditions are if f of x is periodic function, such that first f of x is finite, single valued and integrable in given interval. That's the first condition. Second, f of x has finite number of finite discontinuities. Finite number of finite discontinuities. And third condition is f of x has finite number of finite maxima and minima. Then it has the Fourier series expansion. These are your conditions, Dirichlet's condition, and then only the function will have Fourier series expansion. Why it is so? Just see. F of x has an infinity over. So I know that cos and sine are bounded functions, and a0 is a fixed value. So if left and right hand side is a fixed value, finite value, bounded value, then this also should be bounded and finite. Yes or no? ये समझ में आ रहा है? Why those conditions are put? Cos and sine, they are bounded between -1 to 1. So their values are fixed between -1 and 1. Isn't it? They never go to infinity. So if f of x is infinite, I cannot compare only. So it should be finite. Sine and cos, again a single value. F of x should be single value, because if it is not single value, which values I am going to take? Suppose it is, say, sine inverse x and it has 0. So sine inverse of 0 can be 0, can be pi, can be 2 pi, and so on. So for sine inverse x, if 0 is there in the domain, we cannot write down the Fourier series expansion because it is not single value. Okay? Then finite number of finite discontinuity. Other discontinuity hai, then it is fine. I'll just draw a graph here. Suppose between 0 to 1, your function is defined. Your function is f of x, which is defined between 0 to 2. It is said it is periodic between 0 to 2. Then there is a discontinuity at 1. Can you see? There is a discontinuity at 1.
Yes.
So what is the discontinuity? Is it infinite? Is it becoming infinite?
No.
No. So from right, suppose this value is 2 and this value is 1, say. Yeah. So left hand side limit is 1, right hand side limit is 2. So if I take the average, I will be able to redefine the discontinuity and I will get some fixed value which is finite. So यहाँ पे भी function infinite नहीं हो रहा है. So again it is well defined and finite, and therefore even if it has discontinuity, it should be finite. For example, if f of x is equal to 1 upon x minus 2, 1 upon x minus 2, and 2 is there in the interval. This function will have infinite discontinuity at 2. When x is equal to 2 क्या हो जाएगा वो 1 by 0 हो जाएगा ना, तो infinity हो जाएगा. तो this function we cannot write Fourier series because it has discontinuity at 2 which is infinite. तो अगर discontinuity भी है तो वो finite होनी चाहिए. Then I can write Fourier series expansion by redefining it as average of the left hand limit and right hand limit. Average of the left hand limit and right hand limit. Is it okay?
Yes, ma'am.
Yes.
Yes.
Okay.
Yes.
Similarly, if it has infinitely many maxima minima, अगर एक फंक्शन है इंटरवल में दिया है और वो बहुत वेरी हो रहा है, मैक्सिमा भी बहुत सारे इनफाइनाइटली वेरी है, मिनिमा भी है, तो एक्चुअल सम जब लेंगे हम लोग उस फंक्शन का, तो इनफाइनाइट दिस ऑल दिस थिंग्स व्हिच आर infinite will give me answer which will be infinite. So again, well defined will become a problem, and hence if it has maxima minima, it should have finite number of maxima and minima, because ultimately I am doing what summation, which should become finite. Is it okay?
Yes, ma'am.
Yes, ma'am.
Okay, so these conditions were put for expansion of the function in Fourier series. So those are called as Dirichlet's condition. So Fourier along with Dirichlet defined all these conditions, and then he was been able to write down all these things. Basic requirement सबसे पहला उन्होंने जो शुरू किया था वो partial differential equation and ordinary differential equation, heat conduction, which you are going to study in M3. So those solutions are given with the help of Fourier series. So that was one way. After that, your electronics. In that there were square waves. So those square waves were tried to fit in sinusoidal waves so that your transformers, your motors can understand them. And for that, if you just see a square wave, it is not very smoothly. So the period is not exactly as sine. So sin x, sin 2x, sin 3x, cos x, cos 2x, cos 3x, those terms will try to manage that period which is of a square wave. So I have shared one video. Everyone, please, I have shared a video on your Google Classroom. You go through that. Need of Fourier series. In that, it is very nicely explained. After our unit test, we will try to discuss it. One of you can take it as a topic for presenting to the entire class also. You go through the video, okay? And you will understand why, what is the need, right? That's content beyond the syllabus. So I have already put it in your Google Classroom. So first of all, definition is clear to everyone. Why the conditions are clear to everyone?
Ma'am,
Yes,
can
ma'am.
you repeat the first condition of?
F of x is finite.
Yeah, ma'am.
Yeah. If suppose f of x is infinite, then what is happening? See here, cos and sine. These are bounded function. What are the values of cos and y? It bounded between -1 and 1. So I'm going to
Yes,
write
ma'am.
infinite function has to be a sum of finite values, which is not possible. No?
Yeah, ma'am.
Again, single value. Why single value? If f of x is becoming not single value, so it can take any value, sine inverse x, suppose for example, sine inverse of 0. Sine inverse of 0 is 0 as well as pi as well as 2 pi. So if these points are there in your domain, then it will become a problem. Which one to take? Sine inverse.
Yes, ma'am.
Okay, so single value will be important. Integrable cube, look here. What is a naught? A naught is integration of f of x. So अगर f of x integrable नहीं होगा, तो how can I write down this Fourier series? That's
Okay,
why
ma'am.
integrable is also.
Okay.
So all 3 points. Is it okay? Clear?
Yes,
everyone?
ma'am.
Yes, sir.
Anything else that you want to ask? Good, you are asking.
No.
Okay, fine. So that's the definition, and we'll start with one example so that you will understand how we are going to solve this question. And then I will write down the general formula for 0 to 2 pi minus n to n and so on. So take down. Find Fourier series expansion for Fourier series expansion for f of x is equal to x. F of x is equal to x in the interval 0 less equal x less equal 2 pi, 0 less equal x less equal 2 pi, with period 2 pi, with period 2 pi, with period 2 pi. This is your question, huh? F of x is just x, and we are going to write it as an infinite series sum with the help of sinusoidal, cos wave and sine wave. Okay, so how we are going to do that? It is said that it is periodic, and obviously if I am asking for Fourier series, it will satisfy the Dirichlet's condition. Is it anytime infinite?
No.
Is it anytime what do you say, non-differentiable or discontinuous? X. is a straight line, na? F of x is equal to
Yes.
x is a straight line, so it is continuous. Then maxima, minima, your interval is bounded 0 to pi, so maximum value is 2 pi, minimum value is 0.
Yes.
Correct? So, and remaining things also. What is the thing? What else you want? क्या था और? Single value. Obviously, at each point it will take the value itself. F of 0 is 0, f of 1 is 1, f of 2 pi is 2 pi. So it is satisfying all the Dirichlet condition. That's why Fourier series is possible. Okay?
Yes, ma'am.
Yes.
Yeah. So that's why we will write
Yes.
down. Okay. So what is the comparison? This should be compared with c less equal x less equal c plus 2l. Therefore, c plus 2l minus c is equal to upper limit minus lower limit. That is 2l is equal to 2 pi. So l is equal to pi. L is equal to pi. And therefore, L is equal to pi. Therefore, your function which is f of x can be written in Fourier series expansion as this. You got L, you write down Fourier series expansion of f of x is nothing but a naught by 2 plus summation n from 1 to infinity an cos of n pi x by l plus bn sine of n pi x by l. This is your Fourier series with the formulas of a naught, an, bn given. These are your formulas of a naught, an, and bn. Okay? ठीक है ना?
Yes, ma'am.
So you put the value of L now first. So it is a naught by 2 plus summation n from 1 to infinity an cos of, I should have read directly. No, for the first example, let me write down. N pi x by pi plus bn sine of n pi x by pi. So pi and pi will get cancelled and you will get the answer as to be an cos nx plus bn sine x. This summation is for both the terms. Okay, clear? Everyone?
Yes. Yes, ma'am.
So now our job is to find this coefficient. These are called as Fourier coefficients or harmonics. A naught by 2 is the constant part. An is the coefficient of cos. Bn is the coefficient of sine. So what is the formula for A naught? A naught is 1 by n integration c to c plus 2l f of x dx. So what is L? L is 1 by pi integration 0 to 2 pi f of x is x dx. So you should know integration and then that will give the value of a naught. So a naught is equal to 1 by pi integration of x is x square by 2 from 0 to 2 pi. Integration of x is x square by 2. Substitute this, that is the value of a naught. So 1 by 2 pi into 4 pi square. So what's the value? 2 pi. So a naught is 2 pi. Clear?
Yes, ma'am.
Now let's find out what is an. I'll find an and then you try to find bn. Okay? What is an? 1 by pi. I'm writing directly. This formula I'm using. 1 by l integration. So 1 by pi integration 0 to 2 pi. What is f of x? X. What is cos of n pi x by l? Cos of nx. I'm writing it directly now. ये लिखने की जरूरत क्यों पड़ी? If I write this directly now, an is the coefficient of cos nx. So here it will be f of x into cos nx. And then do the integration. How will you do this integration? I had told C. Which formula I want to use? Which formula I want to use? Yes. What is that product formula? We are going to use Bernoulli's formula. Integration of uv is u v1 minus u dash v2 plus u double dash v3 and so on. Do you remember this formula? Bernoulli's formula for product rule. I have given you this formula. Everyone?
Yes, miss. Yes, ma'am.
Yes. So just see now, you listen carefully. In there you write down. U is x, cos nx is v. So the formula says integration of u into v is u as it is, that is x as it is. First integration of cos nx. What's the first integration of cos nx? I'll write it here. U is
Sin
x.
x by n.
1 pi x.
Yeah. U is x, U1 is 1, and U2 will be 0. V is cos of nx. So V1 will be sine of
Sin
nx
nx
upon
upon n.
n. And V2 will be, what will be V2? Minus cos of nx upon, yes.
N square.
N square.
Everybody is understanding this. If you want, I will write it once.
Yes.
1 by n as it is, sin nx ka integration minus cos nx upon n. And therefore, V2 is minus cos nx upon n square. Is this okay? So, I will write it here. यहाँ पे लिख लूँगी. U as it is into first integration, that is sin nx by n. From where to where? 0 to 2 pi. Minus u dash. So u dash is 1 into one more integration of this, that is minus cos nx upon n square. From where to where? 0 to 2 pi. After this, all the terms are 0. After this, all the terms are 0. So what's the value of an? Therefore, have you written this?
Yes.
F of x is equal to x. This
Yes,
part?
Oh,
Yeah.
yes, yes.
And pi राहिला खाली. 1 by pi.
Which one? I've written here outside, na 1 by pi. Which pi you saying?
Yes, ma'am. That only 1 by pi.
So therefore, an will become 1 by pi inside the bracket. Now put the values. X, here you have 1 by pi. So put the value of x is equal to 2 pi. So 2 pi sine of 2n pi upon n. Lower limit is 0 because x is 0. How do you solve? Definite integration, upper limit minus lower limit. So x is equal to 2 pi into sine of 2n pi upon n minus sine of 0 into 0. So x is 0, so that term is 0. Minus of minus plus cos of 2n pi, upper limit, cos of 2n pi upon n square minus cos of 0 upon n square. Is this clear? Upper limit is, in place of x put 2 pi. So it is minus cos of 2n pi upon n square. And lower limit is minus cos of 0 upon n square. This minus of minus already we made it plus. So this is upper limit minus lower limit formula. Is this clear? Everyone? Everyone? Others? This is the only thing which
Yes, ma'am.
is understood. So now check what is sine 2n pi. Sine 2n pi is 0. So this term will become 0. Hey, सगळ्यांना माहिती आहे का sin 2n pi is 0? Everyone knows this. How sin 2n pi is 0? Because n is 1, everything it will become 0. What about cos of 2n pi? What is the value of cos of 2n pi?
1.
1. So it is 1 by n square. And this is minus 1 by n square. Cos 0 is also 1. So what's your answer of an? An is 0.
Yes, ma'am.
An is 0. Is this clear? Everyone? So on the same lines,
Yes.
you try to find Bn. You try to find Bn. Okay?
Yeah, ma'am.
And then that when you write down the values of a naught, an, and bn, that's a Fourier series expansion for f of x. So you try to complete it. If you don't, then I'll be completing it tomorrow. Is this okay?
Yes.
And I'll take your attendance and then.